But we're talking about hundreds of millions of times the mass of the sun. But it's a black hole, so it's small for that much mass.
Wow. Hello everyone, and welcome back to Universal Narratives, a channel dedicated to unraveling the mysteries of the cosmos. Today, we have an extraordinary and jaw-dropping discovery to share with you. Right at the heart of these enigmatic cosmic beasts, scientists have unearthed something mind-blowing and terrifying inside a black hole, challenging everything we thought we knew about these cosmic wonders. Get ready to buckle up because we're about to unveil the astonishing secrets lurking within a black hole's mysterious core. Are you curious to know more? Let's dive in. Black holes are an incredibly fascinating phenomenon that captivates the minds of scientists and enthusiasts alike. According to the brilliant scientist Albert Einstein in his theory of general relativity, the surface gravity near a black hole is so high that even light cannot escape it, trapping everything within its grasp. Unlike other forces such as magnetism or pushing and pulling, gravity is a result of how space and time are curved or bent by objects with mass and energy. Imagine a massive object, like a star, in space. Its enormous mass and energy cause a deep dent or curvature in the fabric of space and time around it. This curved space and time form what we call a gravitational field. The more massive and energetic the object, the stronger its gravitational field, and the deeper the dent it creates. Now, let's talk about black holes. They are some of the most extreme objects in the universe, with unimaginable amounts of mass and energy packed into a tiny space. Their gravitational field becomes incredibly intense, creating a super deep and strong dent in the fabric of space and time. Here's where things get really crazy. The gravitational pull near a black hole is so incredibly strong that it forms what we call an event horizon. The event horizon is not a physical wall, but rather an invisible boundary or point of no return. Anything, be it an unlucky spaceship or even light, that crosses this boundary can never escape the black hole's grasp. It's as if the black hole has an invisible force field that holds everything inside, including light, which is usually the fastest thing in the universe. To emphasize the extraordinariness of this, imagine shining a flashlight. The light beams travel at about 300,000 kilometers per second. But if you were somehow inside a black hole, the speed you would need to escape its clutches would be even faster than the speed of light. According to our current understanding of physics, that's impossible. Therefore, any light that enters a black hole becomes trapped forever, unable to break free. Even light coming from farther away gets bent around it. So when we talk about a black hole, we can't forget about its mysterious boundary, called the event horizon. It's like a point of no return for anything brave or unlucky enough to venture across it. Once something crosses that boundary and falls into a black hole, it's a one-way trip with no turning back. The event horizon isn't something you can physically touch or see. It's more of a mathematical concept that tells us where we can no longer observe what's happening. You might be wondering, how big is this event horizon? Well, it all depends on the mass of the black hole itself. The more massive a black hole is, the larger its event horizon will be. Scientists have even come up with a formula to calculate the radius of the event horizon, known as the Schwarzschild radius. It involves dividing the mass of the black hole by a constant that incorporates the gravitational constant and the speed of light. Now, let's delve into the heart of a black hole, known as the singularity. All the mass and energy of the black hole, no matter how mind-bogglingly huge, is squished and compressed into an infinitely tiny and dense point at the center. We call this point the singularity, and it's like a cosmic heavyweight packing an incredible punch of gravity and curvature. In fact, the singularity has infinite curvature and infinite gravity, which is pretty fascinating. However, our understanding of physics starts to crumble when we try to make sense of what happens at the singularity. It's as if the laws that govern our universe take a break or go on vacation, leaving us scratching our heads in wonder. Scientists are still exploring this enigmatic territory, hoping to uncover the secrets hidden within the heart of black holes. But how do black holes come into existence? It all starts with the life cycle of a massive star. These stars are like cosmic powerhouses fueled by incredible nuclear fusion reactions happening deep within their cores. The specific nuclear reaction that powers our sun, for example, is the fusion of hydrogen into helium. As long as a star has enough hydrogen fuel to keep the fusion going, it remains stable. However, Stars are greedy and want to keep the fusion party going. When they run out of hydrogen in their core, they get a little creative. They start fusing heavier elements like helium, carbon, and oxygen. Each fusion reaction with heavier elements produces less energy than the previous one. To compensate for this, the star has to work harder and burn faster, turning elements even heavier like carbon into magnesium, magnesium into silicon, and so on. This process continues until the star reaches the critical point where it can no longer produce sufficient energy through nuclear fusion. At this point, the core of the star collapses under its own gravity, giving rise to a catastrophic event known as a supernova. During the supernova, the outer layers of the star are expelled into the surrounding space, while the remaining core undergoes gravitational collapse. If the mass of the collapsed core exceeds a certain threshold, known as the Talmud-Oppenheimer-Volkoff-Tov limit, the gravitational force becomes so intense that not even neutrons can withstand the collapse, and the core collapses into a point of infinite density, called a singularity. This is when a black hole forms, with a region around the singularity called the event horizon, beyond which nothing can escape the gravitational force of the black hole. Ultimately, the star exhausts its nuclear fuel and can no longer sustain the fusion reactions that counterbalance its gravitational collapse. At this stage, the balance between gravity, which pulls the star inward, and the outward pressure generated by the nuclear reactions is disrupted. Without the counteracting force of fusion, gravity takes over, causing the star to collapse under its own weight. The collapse of a massive star is a cataclysmic event. As the star's core collapses, it releases an immense amount of energy in a powerful explosion known as a supernova. The explosion disperses the outer layers of the star into space, while the core implodes, becoming incredibly dense. If the core of the collapsing star has a mass between about 1.4 and 3 times the mass of our Sun, it will undergo a transformation into a neutron star. Neutron stars are incredibly dense objects, composed primarily of tightly packed neutrons. They are so dense that a teaspoonful of neutron star material would weigh billions of tons on Earth. However, if the collapsing star's core has a mass greater than about 3 times that of the Sun, the gravitational forces become so overwhelming that not even the neutrons can withstand the collapse. The core collapses further, compressing matter to an extreme degree. The result is the formation of a black hole. The formation of a black hole marks the point at which the singularity, that infinitely dense and tiny point, comes into existence. The singularity is surrounded by the event horizon, which is the boundary beyond which nothing can escape the gravitational pull of the black hole. So, to recap, black holes are formed from the remnants of massive stars that have exhausted their nuclear fuel and undergone a gravitational collapse. The collapsed core forms a singularity at the center, surrounded by an event horizon that marks the point of no return. While the singularity itself remains a mysterious and puzzling concept, scientists continue to explore and theorize about the nature of black holes. The study of black holes plays a vital role in our understanding of the universe, as they provide unique insights into the fundamental properties of space, time, and gravity. As our journey into the depths of black holes continues, we hope to uncover more about their inner workings and perhaps unravel some of the greatest mysteries of the cosmos. Stay tuned for future discoveries and revelations as we delve further into the enigmatic realms of black holes. This concludes our discussion for today. Thank you all for joining us on Universal Narratives. Remember to keep looking up at the stars and never stop exploring the wonders of the universe. Until next time.